Hello guys and welcome back. In this video we are going to see the VSX routing concepts. The traffic routing feature in VSX network topology are analogous to those available for the physical networks, as we use all virtual network here. So whatever the routing we deliver using the physical network, physical topology, it's not that much similarities you can find here. So we'll be discussing a lot of sections here. So we'll start with the routing between virtual systems. Routing between virtual system, VS. To perform this routing, consider the diagram, and here I can say this number one network is your VLAN, say 100 network, and this number 7 network is VLAN 200 network. Then if you see, this is your VLAN switch number 2. Number 3, you can say VLAN trunk, and these are your virtual systems number 4 and 6. And number 5 is your virtual switch. So this is your virtual switch. So if you have a setup like this, how the routing happens between them, let's understand that. So consider the traffic from VLAN 100 is going to VLAN 200. So say this is the host 1, he wanted to communicate to this host which is located at VLAN 200. How the packet will flow? So consider this host 1 is processing or sending the packet P1. So traffic from the VLAN 100 host first arrives at this VLAN switch. So consider the packet P1 will reach here, and here the VLAN switch insert a VLAN tag. So as per the switching functionality, the tags get inserted with the packet and it's sent to the VSX gateway by VLAN trunk. So via this route, the packet will send to this VSX gateway. So this VSX gateway, the packet will reach to this VSX gateway. So consider the packet is here now, P1. So based on the VLAN tags, the VSX gateway assign the traffic to the virtual system, right? So this VLAN tags, consider it says this packet need to be assigned to a particular virtual system. So this packet will assign to, say, virtual system 1. Now this virtual system 1 do all firewalling work on this packet. So basically it inspect the traffic according to the security policy and send this P1 packet, which is right now here, to the virtual switch. So the packet will go to here. Now packet is at the virtual switch. Based on the routing configuration, the virtual system 1 send the traffic to virtual system 2 by way of virtual switch. So this virtual switch is a L2 switch, so we don't have any routing capability here. So all the routing what we have is on this VSX virtual system. So based on the routing what we have here, the routing part, this packet will send to the next virtual system. Say here the packet will come here. Now the virtual system to inspect the traffic according to its security policy, is do all the firewalling work, and again insert a VLAN tag and send it back to the VLAN switch, right? So from here all the traffic processing happen, VLAN tags get inserted, and then this virtual system will send packet back to this VLAN switch. Now here the VLAN tag is added and the destination is here. So what will happen, the VLAN switch will send that packet to its destination as per the tag. This is what the scenario when we talk about the routing between the virtual systems. Now we understand the packet flow. Now let's understand route propagation. When a virtual system is connected to a virtual router or a virtual switch, we can choose to propagate its routing information to adjacent virtual devices. This feature enables network nodes located behind the neighboring virtual system to communicate without the need to do manual configuration. Route propagation basically works automatically, updating virtual device routing table with route leading to the appropriate virtual systems. Let's take a look of route propagation using virtual routers. So when virtual systems are connected to virtual routers, VSX propagate route by automatically adding entries to the routing table contained in the virtual routers. Each entry contains a route pointing to the destination subnet using the virtual system route side warp interface as its next hop. So basically consider if this is a virtual router and the route propagation is configured. So using the virtual router's warp link, so this is a warp link, this all communication happens. Similarly, route propagation using say virtual switch. When virtual systems are connected to the virtual switch, the VSX propagate route by automatically adding entries to the routing table in each virtual system. Each entry contains a route pointing to the destination subnet using virtual system warp interface IP address. Same phenomena happen. Only thing is that instead of the virtual router, the virtual switch come into the picture, but the warp link is playing important role here. Now let's understand the important concept, which is overlapping IP address space. VSX facilitates Connectivity when multiple network segments share the same IP address range. We call IP address space. This scenario occur when single VSX gateway protects several independent network that assign IP address to the endpoint from the same pool of IP address. Thus, it is feasible that more than one endpoint in a VSX environment will have the identical IP address, provided that each is located behind a different virtual systems. So consider this is your one network, it may be having a different host. So this is what the network connected, and there will be the another network, right? And this is another network. Of course, this VS hosting the IP range, consider 10.0.0. Slash say 16 for now, and this also hosting the same range. Sometimes the IP overlapping happens, but provided it's on a different virtual systems, right? So overlapping IP space in a VSX environment is possible because each virtual system maintains its own unique state and routing table. Because of the routing table and the maintaining the unique state table, this overlapping IP address issue will not occur. So basically this state and routing tables can contain identical entries but within a different and segregated context, right? Of course, two different virtual systems will be having a two different virtual contexts, call it VRF. We already discussed that on previous videos. So the virtual system uses NAT to facilitate mapping internal IP address to one or more external IP address. So consider this is one scenario where I have say IP address 1.1.1.1, and here we have IP address 2.2.2.2, and this is this network having the subnet 10.10.10.0/24, and this network also having the same subnet. So in this case, the network 1, say this is network 1 and this is network 2. So network 1 and network 2 share the same network address pool, which might result in identical overlapping IP addresses. To prevent this, the packet originating from or targeted to these networks are processed by their respective virtual systems, and using NAT to translate the original overlapping address to unique routing addresses. So basically, is it okay to have these IP addresses similar to this virtual system networks? But provided the feature what we have here, we can do the NATing and hide this IP address behind the different IP addresses. Say this network IP address will hide behind this address, and this network IP address is behind this IP address. In that way, we will achieve this concept which we call overlapping the IP address space. Now, as we know, the NAT is also an important part. So virtual systems support network address translation NAT much in the same manner as a physical security gateway. When a virtual system using either static or a hide NAT connect to the virtual routers, you must propagate the affected route to the virtual routers. So this is what basic constraint there when you use the NAT. So to do such thing, you need to do first, you need to define the NAT addresses to virtual system connect to the virtual routers, and then you need to proceed further. Now let's see what are the dynamic routings we support in a VSX virtual system environment. So let me see dynamic. routing. The virtual device can communicate and distribute routes using dynamic routings. Each virtual device has its own routing daemons. Virtual system supports OSPF, RIP, BJP, and PIM. And virtual router, they support OSPF only. So guys, this is the overview of VSX routing concept. I hope you found this video informative.